So we had talked about a lot of things. Last time we were talking about the factors that affect the speed of a reaction, rate of reaction. और उसमें मैंने बताया था कि the two concepts when it comes to the speed of the reaction. Okay, when two molecules collide, the first thing is that the molecule has old bonds and they must be broken, and then new bonds have to be formed. Okay, that's how a reaction happens. Okay, so first old bonds are broken, and how are old bonds broken? जब वो collide करते हैं, when they collide, the atoms they get knocked out because of the energy of the collision, and they can then rearrange in different ways. So, agar to the bonds are very strong, then the reaction, the collisions have to be very, it has to be a very violent collision. Only then would a reaction happen. And if the bonds are very weak, then they would break very easily, and new bonds can be formed very easily. And it all depends on the collision. लेकिन collision के अंदर भी ना there were two concepts. One was frequency of collisions, the number of times that they collide. Now, frequency of collisions can be very high, but that doesn't mean a reaction would happen. But let's say the frequency of collision is 20,000 collisions per second. But each collision, the collision is very weak, which means the collision is not energetic enough. So the bonds are not going to break and the reaction is not going to happen. Uh, so that leads us to the second point, the effectiveness of collisions. You have 20,000 particles colliding with each other, but how effective? Now, not all 20,000 collisions are going to be effective. उनमें से हो सकता है 500 collisions have enough energy to break these old bonds, and therefore they would be considered as successful collisions. So you need to have another thing, which is effectiveness of collisions or the percentage of successful collisions. ये दोनों combined rate determine करते हैं. ठीक है? You can have a very high frequency of collision, but if the collisions are not effective, then the reaction is going to be very slow. Vice versa, the other thing is you can have a very low frequency of collision, but if each collision is very effective and very energetic, then the reaction speed might be very fast. Okay? So, but it depends on this. If the frequency of collision is too low, then obviously the reaction is going to be slow because not a lot of particles are colliding with each other. खैर ये बात clear है बाहर? Is this clear, Sidra? Is this clear?
Yes.
Yes, sir.
Yes,
अच्छा,
sir.
Okay, now we were discussing what are the factors that are going to affect these two things. So temperature, if you increase temperature, then particles are more energetic and they have more speed. So not only are they bumping into each other more, so there's a higher frequency of collisions, so the number of collisions increase, but they also become more effective as well because they have more energy, so the collisions are more energetic, and therefore, so dono suggest kare both of them increase. There's more frequent collisions and they're more effective collisions as well. So hence the reaction is a lot faster if you have a higher temperature. The other thing that we discussed was concentration, but it only applies to gases and solutions, not to solids. Gases के अंदर, solutions के अंदर होता है, if particles are very concentrated, that means that they're very close together. That means they're going to be more frequently bumping into each other. There's going to be a higher frequency of collisions. But the effectiveness of collisions would not change because the particles are not more energetic. They're just closer together, which is why they're bumping into each other more. So the frequency of collision is higher, but the effectiveness of collision is not higher. The percentage of effective collisions remains the same. So overall, the reaction speeds up. Why? Because of the frequency of collisions. I mean, they're colliding more. Let's say 50 collisions हो रही थी and half of them were successful. Now you're going to get 200 collisions and still half of them are going to be successful. So the effectiveness remains exactly the same, but you have a more successful reaction because a higher frequency of collisions. As a number 3, the third one is pressure. Now pressure is only for gases. Okay, so this factor is only for gases. How does pressure affect? Because gases are the only things that are compressible. So, for example, I have a piston, and that piston has uske top pe na there's a हमने पहले भी ड्रॉ किया था इस तरह का डायग्राम. There's another. अच्छा, there's a piston on top of it. And let's shade this part. So ठीक है, this is my piston and they are the gas particles. ठीक है, and the gas particles are trying to bump into each other. So they are red gas particles and they're blue gas particles. If they bump into each other, they're going to react. Now, if I increase pressure, what would I do? I'm going to push the piston inward. Okay, I'm increasing pressure. So if I increase pressure, what happens? The volume decreases. Okay, volume decreases a lot. If I increase pressure, the volume decreases and the piston starts to move downwards. And the particles then would become closer to each other. So these particles, they would become a lot closer, lot tighter packed because you're compressing them. So let's say the piston is continuously moving downwards. So it has been moved downwards, it has been pushed downwards, and the particles are closer together. So the volume decreases. That indicates volume, that's already written. Particles are closer together. So particles are really close together. So you get more frequent collisions. So they're going to bump into each other more. But again, the particles are not more energetic. So the collisions are not going to have more energy or they're going to be more effective. The speed with which they are colliding with each other, that remains the same. It's just that they're closer together so that you get more frequent collisions. So percentage of effective collisions, they remain the same. Okay, they remain the same. Is this clear? Saad, is this clear?
Yes, sir.
Idam clear?
Yes, sir.
I said number 4. Point number 4 is if you have, as a point number 4 is related to कौन से हो गए? 3 हो गए. So this is surface area. As I explain what surface area is, surface area is surface area का main concept is कि large chunks, if something is present in large chunks, so that has lesser surface area. And if something is present in smaller pieces, as if something is present in smaller pieces, or it's powdered, so there's more surface area. That's a more surface area. Now imagine let's say there's a beaker, and imagine I've put a solid piece of let's say solid piece of NaCl. I'm trying to dissolve it. Okay, now it's going to dissolve. How is it going to dissolve if it reacts with water, right? So there's water all around it. Okay, so there's a solid piece of NaCl. Now the problem with this is, okay, there are all sorts of particles in NaCl. Let's imagine this is a crystal of NaCl, and there are all sorts of particles in the crystal. Now, if I try to dissolve this large piece, then only the outer particles would be able to react. Okay, only the ones on the outside, not the ones that are inside. Okay, so this one has a smaller surface area. Okay, काउंट भी कर लो surface area. The places in which the particles could collide. ये अंदर वाले जो particles हैं ना, the ones that are inside, ठीक है, these blue particles that I'm marking inside, they are not, they're not going to, they're not able to collide, ठीक है, with the water molecules that are around it. तो dissolve करना मुश्किल होगा, ठीक है. Imagine there's a large crystal of a salt and you're trying to mix it in water. तो आप stir कर रहे हो. So if you use a very big piece of chunk, it's not going to dissolve very easily because the surface area is less. So you can count. Let's assume if you can see the boxes, let's assume that each of the boxes is 1 centimeter. So what's the surface area? बल्कि उसका perimeter ले लेते हैं. That's just 3 plus 3 plus 3 plus 3. That's 12 centimeters. ठीक है. Now, similarly, in the next experiment, what I'm going to do is I'm going to break it into pieces. Okay, I'm going to break it into tiny pieces. So I still have the same amount of salt, except for the fact that this time I'm going to break it into pieces, and I'm going to break it in exactly how many pieces? 9 smaller pieces. Okay, so it's exactly the same salt, but broken down into pieces. Now the surface area is a lot greater because water particles would be able to collide from all sides. ठीक है. If you use smaller pieces, powdered करते जाओगे तो surface area और ज़्यादा होता जाएगा. So water molecules would be able to collide from all sides. So even the inner particles would be able to react. ठीक है. पहले issue था कि the inner particles, तो जितना उसको क्रश करोगे ना, the greater would be the surface area. Even you can count the surface area. इसका मतलब not the area. Let's say this is 2 dimensional. इसका perimeter count करो. This is 4 centimeters now. This इसकी boundary, that's 4 centimeters. This is 4 centimeters. तो 12 तो यही हो गया. वो पूरा मिला के 12 था. This is 4. This is 4. So now the boundary is much greater. ठीक है. It's the same amount. इन सारों को इकट्ठा करो ना, you're going to get the same thing. Except for the fact that now the surface areas are a lot greater. Mahad, is this point clear?
Yes.
As I so large chunks, the reaction would be slow. Lesser surface area, and you're going to get less frequent collisions. Surface area comes, less frequent collisions would happen. So slower reaction. And the other one is smaller pieces, more surface area, which means more frequent collisions. Remember, the effectiveness of collisions is the same. It's the same energy. The collisions have exactly the same energy. आप energy नहीं बढ़ा रहे. सिर्फ एक तरीके से effectiveness बढ़ती है, and that is temperature. If you make them more energetic, then the collisions would be more violent. So smaller pieces, you have more surface area and more frequent collisions would happen. And this would result in a much this would result in a much faster reaction. Anyways, so that is surface area. Is that clear? Is it clear? Sal clear? Anna, Sidra?
Yes, sir.
Yes.
Yes.
So remember, powder is going to have a faster reaction if you want to increase the speed of the reaction. Now, number 5, the last point is catalyst. Okay, that's number 5. How does the catalyst speed up the reaction? Now, what a catalyst does is that it increases the activation energy. As a catalyst increases the activation energy. Not increases, decreases. That's incorrect. I said decreases the activation energy, making the collisions more effective. more effective. ठीक है, so what a catalyst does is it focuses on the effectiveness of collisions. So percentage of effective collisions increases. Frequency of collision remains the same. You still have the same number of, as a frequency of collisions, they remain the, I said they remain the same. I said, let me explain this now. Okay. Now, initially we talked about frequency and effectiveness of collision. So I was talking about, let's say there's a hydrogen molecule reacting with a Cl2 molecule, and they're going to Cl2 molecule, and they're going to collide with each other, and that would result in the formation of HCl molecules, two HCl molecules. Okay, so that's your overall reaction. Okay, these two are colliding. Now I explained that. I explained that no matter how many times they collide, how many frequent the collisions are, the collisions have to have a very, very specific energy. Okay, so frequency of collisions matters, but it matters to a certain extent. Effectiveness of collisions also matters. I mean, you can collide them a million times together, but if they're not colliding with enough energy, then the reaction would not. Why do you need energy? You need energy to break these bonds. These bonds need to be broken, and then the products would be formed. So some minimum energy is needed so some minimum energy is needed to make the collisions effective. To make the collisions effective, why do you need a minimum energy? To break old bonds. Okay? If they're colliding a million times, but they're not colliding with enough energy, then the molecule will not break, and new things can't be formed. Okay? I mean, for example, if you're making a chair, so the first thing is you would have to cut the tree. That's you have to break the old bonds. Okay? The tree has to be cut with a जो भी axe है या a chainsaw or anything, and then you're going to make new bonds, and you're going to make a chair and connect it in a different way. Okay, so the first step is if the bonds are very strong, then a lot of energy is needed to make the collision effective. So some minimum energy is needed to make the collisions effective to break old bonds. They have to be broken first. And this minimum energy is the activation energy. Okay, some minimum energy is needed, and that's your EA. That's known as EA, or also called your, it's also referred to as your activation energy. ठीक है, ये clear है? Mahad, is this clear? Siddha, is this clear? Iram clear है? Activation energy क्या है?
Yes, sir.
और अच्छा, उसका real world example है कि let's say you have a piece of paper, and the piece of paper there's, so what is combustion? Combustion is a reaction, not a piece of paper. Let's think of a match. Okay, so there's this match, and this match needs to burn. Now the reaction is simple. It's this match reacting with the oxygen molecule that are already in the air. Okay, so there's oxygen molecule already in the air, present in the air. That is combustion. You need air for combustion. These oxygen molecules, they come in, they collide with the match, but nothing happens. Okay, so you keep a match in front of you, nothing would happen. Okay, why would nothing happen? Why? Because the oxygen molecules are not bumping into this match with enough force, with enough minimum energies. So the oxygen bonds, they don't break. and no new thing forms. So how do you burn a match? You strike it, you give it energy. ठीक है, आप जोर से उसको strike करते हो. Either strike it or in some way give it energy. ठीक है, you provide it energy. So there are different ways of giving this match energy. One is to strike it very violently. If you strike it violently, some of the oxygen molecules might get trapped in the process and they would hit the match with a lot of force. And in that process, the old bonds would break and new bonds can then be formed. Or you can put it in front of a flame or any hot object and the match will catch fire. Why? Because the oxygen molecules are going to gain energy and they would bump into this match very, very quickly. And the match would light up and the reaction would start. Okay, so that's an example of activation energy. Okay, you hitting the match, the side of a matchbox with a match. That's you basically giving it the minimum energy that is needed to get rid of the old bonds so that some new bonds are formed and the reaction starts. Okay, is it clear about Sidra? Is this clear? Saad, clear?
Yes.
Yes, sir.
अच्छा, so this is activation energy. अब catalyst का काम क्या होता है? What a catalyst does is it decreases this activation energy. It makes it easier for the reaction to happen. मतलब मैच वाली reaction ले लो, इसमें why do you need a minimum amount of energy? ठीक है, why do you need a minimum amount of energy? क्योंकि the reason is कि oxygen के जो molecules होते हैं they have a double bond. So it's kind of hard to break the double bond. तो इसलिए कुछ reactions होते हैं जिनको energy नहीं चाहिए होती. They happen very violently at room temperature. क्योंकि उनकी जो minimum energy required है ना, that's requirement बहुत कम होती है. Why? Because their old bonds are very weak. Oxygen के केस में ना ये combustion वगैरह पेपर को भी आग लगाना है ना, you have to give it energy first and then it burns. The same applies to wood as well. So the old bonds are kind of strong. If the old bonds are strong, तो उनको तोड़ना बड़ा मुश्किल होगा. So you would have to really give it. Well, it's going to have very high activation energy. So what a catalyst does is it actually kind of, without giving energy, it actually makes it easier to break this bond. यानी अगर यही काम आसान हो गया तो ये जो एनर्जी है जो आपको देनी पड़ रही है, ठीक है, to burn a match, that would not be needed then. So that is what a catalyst does. Catalyst makes it very easy for you to break the old bonds and it decreases the activation energy. So अगर catalyst होता ना कोई हमारे पास, this match would start burning on its own. ठीक है, you wouldn't have to give it energy क्योंकि catalyst आधा काम कर लेते हैं. Catalyst, that is the sole purpose of a catalyst, that it makes it really easy to break those old bonds which previously were very difficult to break. ठीक है, Ahmed, clear है ये? Sano, clear है?
Yes.
अच्छा, तो ये मैंने यहाँ पे लिखा हुआ भी actually, ठीक है. So catalyst decreases the activation energy. यानी basically it makes it very easy to break the old bonds, making the collisions more effective. Frequency of collisions remain the same. यानी इसका मतलब ये कि you're having 100 collisions per second. That's the frequency of collisions. ठीक है, so let's say collisions per second. Now, previously, not all were successful. Let's say 10 of them were effective, or we can say 10% was effective. Now, if you add a catalyst, you're still having 100 collisions per second, so the frequency of collisions doesn't change. But now, because breaking bonds, old bonds is easier because of the catalyst, so 50% of the collisions are now effective. Okay, so the catalyst has somehow weakened the old bonds. So they break easily and the reaction happens a lot easier. So now out of 100 collisions, 50 of them are effective, they're successful. So overall reaction speed would increase. Why? Not because of the frequency of collisions, but because they're more effective now. Okay, is this clear? Maad, is this clear? Is it clear?
Sir,
Yes.
catalyst doesn't provide the extra activation energy. It only just weakens the bond. Is it correct?
हाँ, exactly. मैं एक example में देता हूँ ना कि remember, मतलब मैं थोड़ा सा explain भी कर देता हूँ वो किस तरह करता है ये, ठीक है? और ये मतलब वैसे ही समझाने के लिए, ठीक है, no one is going to ask you about this. If you remember one thing कि transition metals जो है ना, they're very good catalysts. ठीक है, so transition metals मतलब पूरे प्योर टेबल में ना ट्रांजिशन मेटल्स ही अच्छे कैटलिस्ट होते हैं, वेरी गुड कैटलिस्ट। ये हमने मेटल्स में किया था, ठीक है, दे वेरी गुड कैटलिस्ट। और ये भी पीछे हमने वी डिड हेबर एंड कॉन्टैक्ट प्रोसेस, तो उसके अंदर हेबर प्रोसेस में देयर वाज आयरन दैट वाज द कैटलिस्ट, कॉन्टैक्ट प्रोसेस में वैनेडियम पेंटाऑक्साइड वाज द कैटलिस्ट, ठीक है। सो ये भी हमने किया। अच्छा, सो दे वेरी गुड कैटलिस्ट। व्हाई दे गुड कैटलिस्ट? पीरियोडिक टेबल में होता है कि ये रफ सा पीरियोडिक टेबल है, एक साइड पे मेटल्स होते हैं, ठीक है, दिस साइड इज मेटल्स एंड द अदर साइड इज नॉन मेटल्स। अच्छा, पूरे प्योर टेबल में बेसिकली ट्रेंड क्या होता है? ये साइड इलेक्ट्रॉन्स दे लूज इलेक्ट्रॉन्स एंड दिस साइड इट ट्राइज टू गेन इलेक्ट्रॉन्स। व्हाई? क्योंकि एज यू मूव टू द राइट, ठीक है, जैसे ही आप राइट साइड पे मूव करते रहते हो, द एलिमेंट्स हैव मोर प्रोटॉन्स। मतलब कोई भी रो उठा लो ना, कोई भी पीरियड उठा लो, सो एज यू मूव टू द राइट यू हैव मोर प्रोटॉन्स, जिसकी वजह से ना the element instead of losing electrons starts to gain electrons, क्योंकि if you have more protons तो न्यूक्लियस में ना पॉजिटिव चार्ज ज्यादा होगा, तो इट्स गोइंग टू बी अट्रैक्टिंग इलेक्ट्रॉन्स मोर स्ट्रांगली, ठीक है। तो इसलिए मेटल्स दे लूज इलेक्ट्रॉन्स, नॉन मेटल्स दे लाइक टू गेन इलेक्ट्रॉन्स। सोडियम यहाँ पे पड़ा हुआ है तो 11 प्रोटॉन्स है, क्लोरीन इज ऑन द अदर साइड दैट 17 प्रोटॉन्स, तो ऑब्वियसली वो इलेक्ट्रॉन ज्यादा स्ट्रांगली अट्रैक्ट करता है। नाउ ट्रांजिशन मेटल्स, वेयर आर ट्रांजिशन मेटल्स? वो दे आर समवेयर इन द मिडल। अच्छा, ट्रांजिशन मेटल्स आर समवेयर इन द मिडल, इसका मतलब है कि दे काउंटेड एज मेटल्स, लेकिन उनकी जो इलेक्ट्रॉन वो थोड़ा सा राइट की तरफ होते हैं, ठीक है। सो एज यू मूव टू द राइट दे काइंड ऑफ डेवलप दिस टेंडेंसी टू स्लाइटली गेन इलेक्ट्रॉन्स, ठीक है। मतलब जैसा प्लैटिनम है या गोल्ड है, गोल्ड कभी भी आयन नहीं बनाता, ठीक है। व्हाई डजंट इट फॉर्म आयंस? क्योंकि गोल्ड के प्रोटॉन्स इतने ज्यादा हैं कि वो उसके इलेक्ट्रॉन्स को बहुत स्ट्रांगली अट्रैक्ट करते हैं, तो गोल्ड डजंट लाइक टू लूज इलेक्ट्रॉन्स, बट इट्स वेरी हार्ड फॉर गोल्ड टू लूज इलेक्ट्रॉन्स। तो जैसे प्लैटिनम उससे भी इनर्ट होता है, प्लैटिनम रिएक्टिविटी का मतलब ही ये था, रिएक्टिविटी सीरीज वी डिड रिएक्टिविटी सीरीज, तो उस पूरी रिएक्टिविटी सीरीज में यही इशू था कि वो एज यू मूव टुवर्ड्स ट्रांजिशन मेटल्स the metals became less and less reactive, they refused to lose electrons. अच्छा खैर, how does a catalyst do that? अब remember the Haber process, Haber process में ना नाइट्रोजन का मॉलिक्यूल था और हाइड्रोजन का मॉलिक्यूल था। अच्छा, ये रिएक्शन जो है ना, दिस इज इम्पॉसिबल टू हैपन, मतलब इसके लिए बहुत एक्सट्रीम कंडीशंस चाहिए। क्यों? क्योंकि NH3 बनाना है ना। अच्छा, why do you need a strong, why do you need a very high activation energy for this? क्योंकि N and N have a triple bond, it's very hard to break this triple bond। मतलब जो H का मॉलिक्यूल होगा ना, it has to come in and collide with it very violently, ठीक है। once it has a very violent collision with this, तब शायद जाके ना ये N triple bond might break। तो it's actually extremely hard to break this N triple bond, so it's extremely hard to break this N triple bond। अब कैटलिस्ट क्या करता है? वो जैसा हेबर प्रोसेस में ना आयरन का कैटलिस्ट है, इफ यू पुट अ आयरन कैटलिस्ट, तो अभी मैंने एक्सप्लेन किया है ये प्योर टेबल से कि जब आप राइट की तरफ मूव करते हो ना, तो ट्रांजिशन मेटल्स आर द मेटल्स दैट आर काइंड ऑफ टुवर्ड्स द राइट। मतलब आपके ग्रुप 1 मेटल्स होते हैं, ग्रुप 2 मेटल्स होते हैं, फिर ट्रांजिशन मेटल्स आते हैं। तो बिकॉज दे हैव मोर प्रोटॉन्स, सो दे हैव दिस टेंडेंसी टू वीकली अट्रैक्ट इलेक्ट्रॉन्स। तो अगर मैं आयरन डाल देता हूँ ना यहाँ पे, वो क्या करेगा कि, नाउ लिसन टू दिस वेरी केयरफुली, यहाँ पे ट्रिपल बॉन्ड में क्या होते हैं? इलेक्ट्रॉन्स होते हैं। तो व्हाट इट वुड डू इज कि वो आहिस्ता आहिस्ता ना इट्स गोइंग टू स्टार्ट अट्रैक्टिंग दोस इलेक्ट्रॉन्स टुवर्ड्स इटसेल्फ। तो ये बीच वाले जो इलेक्ट्रॉन्स जो पहले बीच में थे ना, the ones that were in the middle, those electrons are going to get pulled towards iron. Is it? ये बात समझ आई है? Sidra, did you understand this? Iram?
Yes, sir.
Yes.
अच्छा, but so in this process by default ट्रिपल बॉन्ड किधर गया? वो ऑटोमेटिकली टूट गया, ठीक है। so all the electrons that were in the triple bond over here that were being shared between the two atoms, वो सारे electrons they kind of got attracted very slightly towards iron, तो अब आपको एनर्जी नहीं चाहिए. Now you don't need a lot of energy to break the triple bond. Ahmed, clear है? Mahal, clear है?
Yes.
Yes.
The same would pretty much go for the other one. The electrons which were in this single bond, they would also get attracted to iron. अच्छा खैर, and the other thing is another reason why transition metals are very good catalysts is कि they don't attract these electrons very strongly. यानी इसका मतलब है कि अगर N bounce back करेगा ना after hitting the catalyst, I mean there's a catalyst piece and the nitrogen molecule came in and hit the catalyst, and if it flies off, तो आयरन उसके इलेक्ट्रॉन्स को इतना स्ट्रांगली अट्रैक्ट नहीं कर रहा कि उसको पुल करके अपने साथ जोड़ ले. सो इट विल अलाउ इट टू फ्लाई ऑफ. सो अगर नॉन मेटल होता ना, मतलब राइट की तरफ जाते रहो ना, नॉन मेटल्स हैव अ वेरी स्ट्रांग टेंडेंसी टू गेन इलेक्ट्रॉन्स. तो इंस्टेड ऑफ आयरन इफ देयर वाज अ नॉन मेटल तो इलेक्ट्रॉन्स पकड़ के अपने पास ही बैठ जाता, उसको लेके अपने साथ बैठ जाता, उसको जाने नहीं देता क्योंकि इट हैज सो मेनी प्रोटॉन्स. सो द गुड थिंग अबाउट ट्रांजिशन मेटल्स इज कि they actually just attract the electrons just a tiny bit, not that much. So it allows the nitrogen to sort of roam around freely. उसको escape भी करने देता है, जाने देता है. और जब वो नाइट्रोजन का मॉलिक्यूल उसको आके हिट करता है तो उसको इलेक्ट्रॉन्स को ना थोड़ा सा स्लाइटली अपनी तरफ अट्रैक्ट करता है, which kind of breaks the triple bond. अच्छा, now the collisions are going to be a lot more effective. अब नाइट्रोजन ने क्या करना है, H के साथ जुड़ना है and it would form an NH3 molecule. ठीक है? Is this clear to everyone? साथ clear है?
Yes, sir.
अच्छा, ये बस मैंने explanation दी थी कि how does a catalyst do that? ठीक है? How does it happen कि magically a bond which was very strong all of a sudden उसकी collision जो है वो बहुत effective होगी, all of a sudden it starts reacting. पहले वो react ही नहीं कर, याद रखो nitrogen atmosphere में होता है, 78% is nitrogen in the air and it barely reacts with anything. लेकिन आयरन के प्रेजेंस के अंदर ना it's that doesn't mean कि activation energy, ये याद रखना, catalyst helps in breaking the bond. हो सकता है कि ट्रिपल बॉन्ड में से ना it doesn't attract all the electrons, it just attracts a few of the electrons. तो यहाँ पे तो मैंने एक्सट्रीम केस शो किया हुआ है कि the entire triple bond has been broken. तो catalyst just makes it easier or lowers the activation energy. अच्छा, so this is these are the 5 concepts जो आपको ना याद रखने हैं. Starting with the first one, इसमें याद रखना है कि temperature, both frequency and effectiveness increase because they are more kinetic energy. Concentration because particles are closer together, so you have more frequent collisions only. Effectiveness remains the same. Pressure, you have increased pressure, so volume decreases and the particles are closer together, so they bump into each other more, and the frequency increases. Surface area में powdered का किया था कि जितने छोटे pieces करोगे इतना fast reaction होगा because the surface area would increase. And the catalyst का हमने explain कर दिया, ठीक है? So this pretty much is the entire chapter. इसके अंदर ना graphs के ऊपर ना we did graphs earlier, ठीक है? इसके अंदर ना graphs के ऊपर ना I'll just make a few adjustments कि I had told you that if you study the rate of a reaction तो उसमें something is changing, मतलब you're measuring change with respect to time. तो हमने ये सारा पढ़ा था कि if hydrogen gas is being produced in a reaction, you measure the hydrogen gas with respect to time. And I told you that steep reaction, if the curve is steep, that means it's a fast reaction. Volume of H2 is being produced at a very fast pace. And if the gradient comes to 0, the reaction stops. Now, if you change conditions and the reaction speed increases, so the only thing that's going to happen in the graph is, if the reaction speed increases, then it's going to become even more steeper. मतलब end में gas उतनी बनेगी लेकिन it's going to happen like if, for example, if I increase temperature, so that means a faster reaction. तो आपने graph को ना और steep कर देना. Vice versa, I mean over here mass is decreasing, ठीक है? So there's a change in mass measured with respect to time. तो the graph is steep. शुरू में बहुत तेजी से mass change हो रही है and then the mass stops changing. So the gradient is 0, that means the reaction has stopped. If you do it at a higher temperature, so that means the reaction would be a lot faster. If the reaction is a lot faster, then it's going to be steeper. it's going to be a lot steeper and end में mass उतनी decrease होगी, but the reaction would be faster. Slower होगा तो less steep होगा. ठीक है? Is it clear? Iram, Mahat, Sidra, is this clear?
Yes.
चल ठीक है, we'll continue with this. Past clip करेंगे इसके. We're done with this thing. A lot of these things they come in ATP papers. ठीक है, you'll be asked to draw or sketch graphs. तो past clip करेंगे इसकी. ठीक है, next class में. चलिए ठीक है. Any questions about this? कोई question तो नहीं है?
No, sir.
No, sir.
चलिए ठीक है. Okay then, take care. Allah Hafiz.
Allah.
Yeah.
Yes.